The name's Khan. That's it. Ugh. Okay, now the next bit is about the reactivity series and predicting the product of electrolysis, of what we're going to get out of the electrolysis reaction. Now, this isn't the half equations bit, this is talking about what happens first at the negative electrode, then the positive electrode, and then putting it together. We're not going to be doing half equations yet. Okay? So it's about that. Okay, so predicting the products of electrolysis. Ionic substances in the solution break down into elements during electrolysis. They break down into elements. The ionic substances break down into elements. Okay, that's what we're trying to do. We're trying to split them into elements. Now these different elements are released. These different elements are given out depending on what the ionic substance actually is. Okay, so at the negative electrode, positively charged ions gain. This is reduction, because reduction is gain. And you say the ions have been reduced. Now, this is what you need to remember. Metal ions and hydrogen ions are positively charged. Okay? Whether you get these metal or hydrogen elements or atoms during electrolysis depends on the position of the metal in the reactivity series. So, the metal will only be produced if it is less reactive than hydrogen. The metal in electrolysis will only be produced as an element if it is less reactive than hydrogen in the reactivity series. Okay? The hydrogen will only be produced if the metal is more reactive than the hydrogen. Okay? So, yes, we have, I was going to draw it out, the reactivity series, but CBA, because I know we've got it in the classroom, but I'll just read it out. So from most reactive to least reactive, we've got potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. Okay? So if the metal is either copper, silver, gold, platinum, or basically if the metal is less reactive than hydrogen, then it will be produced. It will be given off. The hydrogen will be given off if it is more reactive. The metal is more reactive than it. So the electrolysis of copper chloride solution, say we've got copper chloride solution, the electrolysis of copper chloride solution produces copper at the negative electrode, but the electrolysis of sodium chloride solution produces hydrogen. Okay? Because the metal is more reactive than hydrogen. If you don't understand this, see the teacher after class. Okay, at the positive electrode, negatively charged ions lose electrons, they're oxidized. Okay. So, I'm just going to read some stuff out. Actually, I'm going to draw it. Hold 1 second. Oh my god. Anyway, now hopefully you can read. Oh my goodness, you can read the piece of paper. Okay, so, I have written this, I've drawn up this table, okay? It says negative ion in solution, and then the element given off at positive electrode. So, in the solution, this ion is called chloride, Cl2, it's negatively charged. Oh dear, how do I do this? Okay. Let's just do it like this, okay. And then at the positive electrode, it's called chlorine, Cl2. Because it's become an element. Bromide, the same. Look, just read it, okay? I can't even see what I'm doing. Yeah, okay, there we go. Copy this down if you wish, or not. Okay. Hopefully that explains something. Where is the thing? Okay. Okay then. Yeah. 1 second. Just wait. Just bear with me. Okay. Slow laptop. Purification of copper. Copper is a good conductor of electricity and is used to make electrical wiring and components because it is a good conductor of electricity. The extraction of copper from copper ore is done by reduction with carbon. However, the copper produced is not pure enough for use as a conductor, so it is purified using electrolysis. In this process of electrolysis, the positive electrode, the anode, is made of the impure copper which is to be purified. The cathode is a bar of pure copper. The two electrodes are placed in a solution of copper sulfate. And that is the purification of copper. That's all I got. And then see, on this website there's like, it says, okay, look at this graph below, blah, blah. I can't really do that because, you know, I'm not the ICT genius. It'll be nice if Omar helped me, but thanks, Omar. Even though I didn't ask you for help, but thanks a lot, Omar. Anyway, I'll probably do a bit in class as well, because I can't be bothered to make any more videos. It's just so tiring with all the distractions and everything. So I will see you all. I'll see y'all tomorrow because I'm doing this last minute. So yeah.